By the end of this video, you should be able to expand the binomial expression as a series when the exponent is not a positive integer. That is, it could be negative integer, it could even be fractional, right? Now, we mentioned in our previous video that every term in a binomial series can be written in the form n combination r alpha raised to the power of n minus r and gamma to the power of r. And we can write an expansion of alpha plus gamma raised to the power of n using this, because the first term is going to be alpha to the power of n plus n combination 1 alpha to the power of n minus 1 gamma to the power of 1 plus n combination 2 alpha to the power of n minus 2 gamma to the power of 2 plus n combination 3 alpha to the power of n minus 3, then gamma to the power of 3, and it goes on and on, right? Okay, until you get to the last term. The last term is going to be such that the value of n and the value of what you have here at the bottom are the same, so more like n combination n, and we have gamma to the power of n. Okay, so if we take each of the combinations that we have in the series, right, and we try to simplify them, n combination 1 is going to be n factorial over n minus 1 factorial 1 factorial. N combination 2 is going to be n factorial over n minus 2 factorial 2 factorial. N combination 3 is going to be n factorial over n minus 3 factorial 3 factorial. And the last guy, which is n combination n is going to be n factorial n minus n factorial and n factorial, more like that. Now this is going to be written as n times n minus 1 factorial over n minus 1 factorial 1 factorial. So this is going to cancel this out. I'll be left with n over 1 factorial. 1 factorial is 1, so this becomes n. Now for this, it's going to be n times n minus 1 n minus 2 factorial divided by n minus 2 factorial 2 factorial. Now this divides this, and we'll be left with n times n minus 1 over 2 factorial. Now this is n times n minus 1 time divided by 2, because 2 factorial is 2 times 1, right? Now if we go on with this, it's going to be n times n minus 1 n minus 2 n minus 3, right, factorial divided by n minus 3 factorial 3 factorial. Now this again divides this, and we're left with n times n minus 1 n minus 2 divided by 3 factorial, and that is going to be n times n minus 1 n minus 2 divided by, this is 3 times 2 times 1, which is 6. Now for this guy, this is going to be 1 n factorial of n minus n is 0, 0 factorial is 1, and we have n factorial at the bottom, so this goes to 1. Now the next thing for us is to substitute our newly derived expressions into the series. So which means that alpha plus gamma to the power of n can now be written as alpha to the power of n plus n alpha raised to the power of n minus 1 and gamma, okay, plus n combination 2 is n times n minus 1, over 2. So you have n times n minus 1 over 2 alpha to the power of 2 n minus 2 gamma to the power of 2 plus n combination 3 is what we have here. So n times n minus 1, n minus 2 divided by 6. Then we have alpha to the power of n minus 3, gamma to the power of 3, plus, it goes on like that until we get to the last guy, gamma to the power of n. Okay. Now we can use this understanding to expand 1 plus x raised to the power of n. So we can just take it as alpha being 1 and gamma being x, right? So we have 1 raised to the power of n, which is 1, plus n times, this alpha is consistently 1. So if you are raising 1 to any power, it's still 1, right? So we're just going to be focusing on alpha. So what I meant is that if I take 1 to the power of n, for instance, 1 to the power of n is 1, 1 to the power of n minus 1 is 1, 1 to the power of n minus 2 is 1, 1 to the power of n minus 3 is 1, and so on. So all of this to the power of n, to the power of n minus 2, power of n minus 3, they are all ones. So our attention is just going to be focused on n and gamma, which is x in this instance. So we're going to have nx plus n times n minus 1 over 2. This is 1. Now we have x squared plus n times n minus 1, n minus 2 divided by 6, right? This is 1 again, and we have x to the power of 3. Now this goes on, right? It goes on like that. It's continuous until you get to the last guy, who happens to be x raised to the power of n. Now, this is the concept we are going to be applying. In fact, this formula works if the integer is not a positive integer. That is, if you have n, if n is equal to a negative number, it is going to work. If n is fractional, that is, if it's a rational number in form of fraction, right? So a fraction in this instance, okay, it is also going to work. Whether the fraction is negative or it is positive, is always going to work, right? Now, note that this formula, if you're using it for the power of n that is other than positive integers, that is other than 1, 2, 3, 4, 5, 6, and so on, you should know that the expansion will not terminate. Now, it is glorious that we have this expansion ending at x to the power of n. If it is negative and it is fractional, please do note that it's going to be continuous, as we are going to see in the next example we're going to take. Now, let's say you are trying to expand the root of 1 plus x. Okay, so what you do is write it in index form. This is going to be raised to the power of half, and if you look at the written series, it's quite similar to the one we have here. The only difference is that this is n and this is half. So all we just have to do is to replace all the n's that we have with half. So we're going to have 1 plus nx, that is going to be half x, plus n times n minus 1 is going to be half times half minus 1 divided by 2. Then we have x to the power of 2 plus n minus 1, n minus 2 is going to be half minus 1, half minus 2, okay, this divided by 6. Then we have x to the power of 3. And lastly, let's see, half minus 1, half minus 2, half minus 3, x to the power of 4 divided by 24. So our assignment now is to simplify. So let's do that. So we have 1 plus half x plus half times negative half, okay, divided by 2, x to the power of 2, plus half times negative half, negative 3 over 2, all divided by 6. Then we have x to the power of 3, plus this is half, this is negative half, and this is going to be negative 3 over 2, and it's going to be negative 5 over 2. X to the power of 4 divided by 24. Now this goes on and on and on. Remember that I said that if you have a power that is not a positive integer, okay, if it is not a positive integer, if it is fractional, okay, it means that if you try to write it in an expanded form, then it is not going to be terminating. Okay, so let's go on with our simplification. Okay, so let's start off with this. 1 times 1 is 1 and 2 times 2 is 4. Now here is a negative, it multiplies this. So we have 1 plus half x, right? So this negative multiplies this first. So we have a negative, and here we have 1 over 4 divided by 2. That is 1 over 8x squared. Let's come here. Negative is positive times plus is plus. So we have a plus. 1 times 3, that is 3, right? Okay, so let me just do that here. So we have a 3. Then 2 times 2 times 2 is 8. Now when you divide that by 6, you have 3 over 48, right? So this goes to 1 over 16. So we have 1 over 16 x to the power of 3. Now for this guy, let's multiply all the negatives first. Negative, positive, and this negative, and this negative. So we have a minus, right? So 1 times 3 is 3, and 3 times 5 is 15. So let me just do that here. 15 divided by 2 times 2 times 2 times 2, that is 16. Now divided by 24. Okay, so this means 15 over 16 times 1 over 24. Now when we break this down, okay, if we use 3 to divide this, we have 5. If we use 3 to divide this, we have 8. So we have 5 divided by 128. Okay, so this becomes minus 5 over 128 x raised to the power of 4. It goes on like that, like that. Now this is the expansion up to x to the power of 4 for the square root of 1 plus x. So what if the question says you should expand 1 over 1 plus x? So your line of defense here is to first write this as 1 plus x raised to the power of negative 1. So you know from here that n equals negative 1. Now you come back to your series and then you substitute, right? So we do 1. So we do 1 plus n is negative 1. So we have negative 1 times x. That has been sorted plus. Again, n is negative 1. Negative 1, negative 1 minus 1, x squared divided by 2. Plus negative 1 minus 1, negative 1 minus 2 divided by 6, x to the power of 3. Lastly, okay, negative 1 minus 1, negative 1 minus 2, negative 1 minus 3, x to the power of 4, all divided by 24. It goes on like that. I'm not going to be the one to do that. And here we're going to be having 1 minus x, right? And let's do this. Negative 1 times negative 2 this is going to be plus 2, right? Now, this plus 2, right, divides these two, okay? And that's going to be 1, okay? So we're going to have plus x squared. This is interesting. Right, so this is going to be negative 1 again times negative 2 times negative 3. All of this equal to negative 6. So when you divide, you have negative 1. So this is going to be negative x cubed. You can guess what the next one is going to be. Okay, so this is going to be negative 1, negative 2, negative 3, and this is negative 4. All of this we end up being positive 24, and that divides this. So we have, so this goes in. Okay, so we can go on and on and on. All right. So what if we have some other values other than 1? 1 over 2 plus x, right? So this is 2 plus x raised to the power of negative 1. So all we can do here is to make sure this is written in the form 1 plus x to the power of n, because here we have 2 plus x to the power of negative 1. Okay, so let's rewrite it so that it's going to fit in this narrative, right? So what we're going to do is this. We're going to factorize internally. We do 2 into 1 plus x over 2, right? And this is going to be negative 1 because that is what we have on the outside. Now this means that 2 to the power of negative 1, 1 plus x over 2, then to the power of negative 1. Right? Now 2 to the power of negative 1 is obviously 1 over 2. So we do 1 over 2, then 1 plus x over 2 to the power of negative 1. Now 1 over 2, 1 plus x over 2 to the power of negative 1 can be written as, let's take the half to be on the outside. And let's begin with all of these guys. So we have 1 plus, remember, n is negative 1. So we have negative 1. X is not x, right? X is now x over 2. So we replace that with x over 2. That has been sorted. Plus, and n minus 1 is going to be negative 1 minus 1 over 2. Then we have x over 2 all squared. Plus negative 1 minus 1, negative 1 minus 2, x over 2 to the power of 3, right? And all what we have is divided by 6. So we can go on with that. Okay, let me just stop at the power of 3. Now this is going to be equal to half. Then we have 1 minus x over 2. Now let's come here. This is negative 1 and this is negative 2. When you multiply, you have positive 2 divided by 2, that is 1. So we have plus, this is x squared over 4, right? Now let's come here. Negative 1 times, this is negative 2, right? Times negative 3. So all of this will give us negative 6. When you divide that, you have a negative 1, right? So we have negative x to the power of 3, right? Divided by 8. Now, we need to use this 2 to open the bracket, right? So this becomes half minus x over 4 plus x squared over 8 minus x cubed over 16. Thank you. Now, what if it changes? What if you have 1 over 1 minus x? So what do? First, you know that this can be written as 1 minus x raised to the power of negative 1. So n is negative 1. But we have to be careful about one actor here, which is x. X in this case is negative and not positive. So we can rewrite this as 1 plus negative x, right, raised to the power of negative 1. So we have to be careful in our expansion. So let's go. 1 plus n is negative 1. So we just do negative 1. But our x in this case is negative, so it's not positive, just like we have it here. So it's going to be negative x. That has been sorted. Plus, now n again is negative 1. So negative 1, negative 1, negative 1. Right. X again is negative, so negative x all squared. This is divided by 2. Plus negative 1, negative 1, negative 1, negative 1, negative 2, negative x raised to the power of 3, all divided by 6. And lastly, we have negative 1, negative 1, negative 1, negative 1, negative 2, negative 1, negative 3, negative x all raised to the power of 4, and this is divided by 24, and that is continuous. So let's do 1 negative multiplies negative, that gives positive, then 1 times 1 is x. If you do that, you have plus x. Here we have this is negative 2, right, and this is negative 1. So when you divide and multiply, when you multiply this, you have 2. When you divide again, you have 2, which is positive, right? Because negative x all squared is also positive, so this is going to be plus x squared, right? Plus negative 1 is negative 1 times negative 2 times negative 3. So if you multiply all of this, right, you have a negative 6. Remember that this is going to be negative x to the power of 3, right? So if you multiply the negatives here, you have positive, this and this positive, then this and this positive. So then all of this is 6. So 6 divided 6, that's 1. And you have x to the power of 3. You can guess what the next one is going to be. X to the power of 4, right? Exactly. So this is going to be negative 1, negative 2, negative 3, negative 4, and x to the power of 4. And all of this for positive 24, and it's going to be x to the power of 4. So this goes like that. Now, I would love to say that there is a condition for all of the expansions that we've made. Now, in the case where we had to expand 1 over 1 minus x, we said this is going to be equal to 1 minus x to the power of negative 1. And this, after our expansion, became 1 plus x squared plus x to the power of 3 plus x to the power of 4, etc. Now, this will only work if x is between negative 1 and 1. That is, the absolute value of x must be less than 1. Or we can say negative 1 less than x less than 1. Now let me explain. Now let's take this as the left-hand side. And let's take our result as the right-hand side. Now let's say we are picking a number that does not fall in this range, right? Let's pick a number that is way more than 1. So let's say we have 2, okay? Let's say we have 2. That's a closer number. Let's say we have 2, right? Now x is 2. So we have 1 over 1 minus 2. This is going to be minus 1. If you substitute that 2 to the right hand side, that is our expansion, we're going to be having 1 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4, and so on. Obviously, if you try to do that and you compare the left hand side and the right hand side, you're going to see that negative 1 cannot be equal to all of this. And so that has to be bore in mind, that you should not assume that the value of x goes for any number. All right, so it has to be between negative 1 and 1. The same thing goes for the other expansion we made that we eventually arrived at, I think, x over 2. There's something quite similar. This is also something that must be, the absolute value must be less than 1, Or we can say that negative 1 less than x over 2 less than 1. All right, so this is the condition that caps it all.